At 2:17 a.m., a network operations center in Stavanger, Norway, registered a signal anomaly on a transatlantic fiber-optic bundle. The line remained intact. There was no blackout. Data throughput briefly dropped by 4.3% for 200 milliseconds, a variation an inattentive observer might attribute to subsea pressure fluctuation. The technician on duty logged it, marked it low priority, and returned to the board. Analysts later recognized the 4.3% drop as the first clear sign of contact with the cable housing at 1,200 meters, linking the anomaly to the following event. This contact was deliberate, occurring precisely at a point not listed in any public infrastructure database. No one observing civilian internet traffic noticed any outage. If so, this subtlety was no accident, highlighting the event's calculated nature. Against this subtle backdrop, the central question was not simply whether Russia tried to cut a cable that night. Instead, as the situation evolved, the question shifted to whether NATO had just stopped something less conspicuous and possibly more important, only 14 seconds before its own rules would have prevented any action. The cable junction, Node 7N, lies about 340 kilometers northwest of Bergen, Norway, in the Norwegian Sea. More than a single cable, it is where 4 transatlantic fiber-optic bundles run within 800 meters before splitting toward the United Kingdom, Iceland, and the US East Coast. On any given day, this junction carries a significant share of European-American financial settlement data, NATO-encrypted command traffic, and civilian internet traffic for about 11 million users. Node 7N has less monitoring than other northern NATO sites. The Baltic Sea has Baltic Sentry, but in the Norwegian Sea, a P-8A Poseidon patrols every 18 hours, and a Fridtjof Nansen-class frigate divides its time between tracking submarines and monitoring vessels. Without permanent underwater sensors, wide stretches go unmonitored. Patrol frequency depends on available assets, not risk. Key cable areas go unseen for hours. Such gaps, however, do not arise by chance. They exist because of budget limits. Further emphasizing the strategic nature of this area, the unclassified assessment omitted one detail reportedly included in its classified annex. Russian GUGI mapping vessels had been sighted in this area twice in the 18 months preceding the report. By the time the written report was finalized weeks after the anomaly was initially logged at 2:17 a.m., the mapping by GUGI vessels had already concluded, having taken place prior to the incident. 18 hours before the anomaly registered in Stavanger at 2:17 a.m., at approximately 8 a.m. the previous day, a NATO P-8A Poseidon on a Baltic Sentry Northern Extension mission, using the call sign Norse Watch, detected an acoustic contact about 90 kilometers northwest of Node 7N. GUGI submarines rarely carry torpedoes. Their equipment is engineered for seafloor access, detailed bathymetric mapping, and remote manipulation of subsea infrastructure. Norse Watch tracked the contact for 4 hours and 20 minutes. The submarine stayed at a relatively shallow depth, which is unusual for this type of vessel, and made 2 slow course corrections during this time. Looking back, these maneuvers put it within the best range for deploying an AUV near Node 7N. At the time, the movement seemed prudent, but later analysis saw it differently. At 10:40 p.m., contact went quiet. No confirmed contact. Acoustic signature lost. Thermal layer interference is suspected. Norse Watch deployed 2 more sonobuoys and expanded the search. The loss was logged and reported. NATO's Joint Force Command Brunsum was notified, and the information was included in the overnight intelligence summary. No extra assets were diverted. The frigate KNM Roald Amundsen held position 55 kilometers south, and the contact was judged to have gone deeper. The submarine did not go deeper. Instead, it slowed down. It also moved northeast, heading toward the ferry lane. The MS Vesterollen, a coastal vessel on the Bergen-Kirkenes route, is part of the Hurtigruten network, which has served the Norwegian coast for 130 years. At 12:40 a.m., it carried 312 people north. Its route crossed a 14-kilometer stretch, which, if still tracked by Norse Watch, would have been a restricted monitoring zone. The Vesterollen creates substantial underwater noise. ships at cruise speed mask passive sonar, cutting detection range by up to 60%. A quiet submarine under a busy ferry lane is nearly undetectable without a close sensor. This ongoing pattern is not just concealment. It reflects a deliberate study of NATO's rules of engagement and the restrictions for civilian shipping. This exploitation questions whether the current policy covers adversaries hiding behind civilian traffic. One response: review ROE to allow more flexible active sonar or safety monitoring. Another: expand passive underwater surveillance. Third: create more refined exclusion zones or notification protocols for civilian ships so military assets can act decisively. Each adjustment balances risk, legal limits, and deterrence. But adversaries test boundaries. This deliberate exploitation shows Russia methodically analyzing doctrine, identifying loopholes, and operating to probe NATO's decision points within those boundaries. Thus, when the Vesterrollen passed over the estimated position of the GUGI submarine at 1:55 a.m., just 20 minutes before the cable disturbance at 2:17 a.m. The context for the events that followed was set. There, beneath the ferry, at 2:04 a.m., the KNM Roald Amundsen detected an underwater acoustic target via its hull-mounted sonar. The contact was not the GUGI submarine, but a smaller, low-Doppler, low-speed autonomous underwater vehicle, AUV, descending through the water column toward Node 7N at 300 meters depth on a trajectory to the cable junction. It was a torpedo-shaped AUV dimensioned for internal launch from GUGI's modular deployment bay, operating near quiet. The vehicle was on a pre-programmed variable buoyancy descent, with docking routines targeting subsea cable repeaters, indicating intent to physically interface rather than merely transit. The Amundsen's commanding officer was informed at 2:05 a.m. he was on the bridge in under 2 minutes. The facts were clear, but the choices were not. The AUV's bearing, depth, and descent were tracked. The likely GUGI deployment was unconfirmed, within a 12-kilometer uncertain zone, under and behind the ferry's wake, while the Vesterrollen was moving away. Norwegian rules of engagement for this area allow active sonar in 3 cases. The third applies: a confirmed threat to critical infrastructure that could cause irreversible harm. The question was whether confirmed meant what the commanding officer needed it to mean. This is the decision point that the incident review would spend 3 weeks examining. To fully grasp it, it is worth understanding exactly what the commanding officer knew and did not know at 2:08 a.m. He knew a small autonomous vehicle was headed for a transatlantic cable junction, set to arrive in 4 minutes. If it made contact and installed a device tap, charge, or sensor, the results could be irreversible. Repairs at 1,200 meters take weeks, with no specialized vessels present that night. He did not know if the AUV carried a cutting tool or a reconnaissance sensor. He did not know whether more assets had already been deployed. He also did not know if the Vesterrollen had fully cleared the ROE protection zone, where active sonar can threaten civilian navigation. He had 4 minutes to decide if a likely threat to a cable he could not see justified taking a definite action that would alert a submarine whose position he could not confirm. Once the submarine realized it had been found, it would have every reason to finish its mission before leaving. Signal degraded, contact descending, reacquisition of submarine, not achieved. At 2:09 a.m., the KNM Amundsen's navigator confirmed the Vesterrollen had exited the minimum exclusion radius. By 14 seconds, the commanding officer authorized a single active sonar pulse, 1 ping, targeted at the AUV's last confirmed position. The effect was immediate. The AUV stopped its dive. This was not a malfunction. The change in speed was too sudden and controlled. It had received a command. Somewhere inside the uncertainty area behind the Vesterrollen's wake, the GUGI submarine heard the ping, recognized it as Norwegian hull-mounted sonar, and sent a recall order. The AUV held position for 11 minutes at a depth of 890 meters, 310 meters above the cable junction. Then it began ascending, slowly, controlled. At 2:31 a.m., the GUGI submarine was reacquired by Norse Watch, which had returned to the area after being alerted to the Amundsen's contact report. The submarine was moving north-northeast at 6 knots. Silent, but not aggressively so. It was not evading. It was leaving. By 3:15 a.m., it had passed north of the operational area. Come dawn, it was tracking toward the Barents Sea. No surface vessel made contact with it. No NATO asset shadowed it into Russian waters. It disappeared from passive surveillance at 4:40 a.m. in an area where subsea topography is known to provide significant acoustic masking. The Stavanger Operations Center's 4.3% data stream anomaly was later annotated in the incident report as behavior consistent with an AUV's manipulator or hull briefly making physical contact with the fiber-optic cable housing before receiving the acoustic recall command. There was brief physical contact. This is the detail that the post-incident review marked as the most consequential finding. Not the near miss, not the ROE decision, the contact. Because the question that contact raises is not whether the AUV was going to cut the cable that night. The answer to that question is almost certainly no. Not with a Norwegian frigate now actively tracking the area. Not with Norse Watch inbound. The question is what physical contact with a cable housing enables, independent of severing it. To answer this, you need to know what GUGI AUVs are designed to do. They are made to map and measure. Some versions, which Western naval intelligence believes are used on third-generation GUGI platforms, are also built to place devices. A passive monitoring device the size of a paperback book attached to a cable housing at 1,200 meters would be invisible to surface surveillance. It would not draw power from the cable, would not emit a signal until remotely activated, and would not be detected by any NATO sensor currently in continuous operation in the Norwegian Sea. The incident review concluded that it was not possible to confirm or deny whether the AUV had successfully placed such a device before the recall order reached it. That phrase, "not possible to confirm or deny," appears only once in a 140-page document. It is the most important sentence in the report. There is a basic assumption in NATO's current approach to undersea infrastructure defense that this incident revealed, and no public statement has addressed it since. The assumption is that the main threat is severing, that the goal of a GUGI operation is to cut a cable, cause a visible outage, and create a measurable disruption. Policy responses to Baltic cable incidents have mostly focused on detecting, attributing, and deterring such incidents. But a tapped and monitored cable is not an outage. It becomes an intelligence asset. It continues to run normally and shows no ongoing anomaly. The traffic it carries, which is encrypted but still vulnerable to long-term cryptanalysis, passes by a passive sensor indefinitely, until someone finds the device or it is activated for more than just listening. Russia may not be trying to cut off NATO's undersea cables. It may be trying to turn them into microphones. The commanding officer of the KNM Amundsen made the right decision. The ROE call was correct. The single sonar ping was sent with 14 seconds of legal clearance, the AUV recalled, and the outcome could have been much worse if the timing had been different. But 14 seconds is not part of the official procedure. That was luck, not a planned process. If the GUGI submarine's mission file exists and post-event analysis shows, it almost certainly does. It now contains the following information. The Norwegian frigate waited for civilian vessel clearance before using sonar. The time between detecting the AUV and activating sonar was 4 minutes and 11 seconds. The AUV reached 890 meters before being recalled, which is 310 meters above the target cable depth. Based on the AUV's descent rates that night, the time needed for a physical placement maneuver on node 7N is about 7 minutes. 4 minutes and 11 seconds versus 7 minutes. The gap is 2 minutes and 49 seconds. That is not a long time, and it is not impossible to overcome. The next time the Vesterålen or any ferry on the Bergen-Kirkenes route passes over that area, the real issue is not whether NATO can respond. It is whether NATO's rules of engagement will allow a fast enough response to make a difference. Russia now has that number. It measured it, it tested the protocol, observed the response, and filed the result. The cable was not cut. The AUV came back. The submarine went home, and somewhere in the Norwegian Sea, at coordinates that no NATO sensor currently monitors continuously, Node 7N carries traffic for 11 million users through 4 transatlantic bundles, past a cable housing that may or may not have been touched by something that left nothing visible behind. Baltic Sentry monitors the Baltic Sea. The Norwegian Sea relies on rotating patrols and limited funding. The gap between them is not about geography. It is the gap between what Russia has already mapped and what NATO has not yet acknowledged it needs to protect.